Okay, so now we are recording. So welcome. Today I invited you to a talk about adaptable design upfront. So thank you for coming. This methodology of adaptable design upfront is something that I developed as part of my investigations in the field of software design. Before I was in the field of artificial intelligence and machine learning, I was for many years president of the Israeli chapter of the International Association of Software Architects. Okay, during 7 years, I was president of the Israeli chapter of the International Association of Software Architects. And during this period, I organized several conferences about software architecture and software design. And also, I myself gave many presentations and talks in such conferences and meetups. And also, I wrote a lot on my blog. You know, if you've visited my blog, you know my blog I have been writing for 14 years. Now, in this month of September 2024, it's 14 years I have been writing my blog. So since September 2010. And I have lots of materials, and I like to share. You know, it is important for me to share what I know, or at least what I think I know. And so that's the reason I invited you, and I want to thank you for coming. Just one clarification: what I call software design is not related to what lots of people call design, that is user interface design or user experience design. This is another completely different kind of design. So we are not talking about user interface. We're not talking about user experience. We're talking about software architecture and software design. Okay, so the design of the structure of the system. And normally, when we talk about software architecture, it is the high-level design, and when we talk about software design, it's more the medium and lower-level design. Okay, so let me show my presentation, and perhaps more people will join us later. Opa. Okay, so this is my presentation about adaptable design up front, and I'm afraid that I will not see if someone wants to join. Okay, in a few minutes, I will stop sharing to check if perhaps someone wants to join.
Did we receive a presentation or this recording?
You already saw it?
No. I just want to know after meeting, have we... שיהיה לנו את הכל.
Ken, after this meeting, I will share with you the recording. Actually, the recording, I will put it on YouTube. Okay, so this presentation will be on YouTube. So if for some reason it is difficult for you to participate now, you can leave. This is not a problem. Okay, so if you cannot stay, you can leave. You are invited to stay, of course. And I will share it on YouTube, and also the slides are on SlideShare. And there will be no exam and no exam about this. Okay, so don't worry. Okay, so let's start. So first, we need to define the context. And we were talking about adaptable design upfront, but what is the context? The context is what we call iterative software development. That is development in iterations, in cycles. And in this category of iterative software development, it is all the agile methodologies like Scrum and Kanban in extreme programming, and all what's called the incremental software development. So here, what you see in this picture is what is called a sprint. Okay, so you have this is the Scrum methodology. In the Scrum methodology, you have this concept of the sprint. Okay, so the sprint is normally 2 weeks. Sprint is a typical 2 weeks, and you have a daily Scrum meeting every day. Okay, this is called normally the stand-up meeting. And you have a product backlog. The product backlog is all the user stories or the features you want to develop. And from the product backlog, you select a sprint backlog. The sprint backlog is the user stories that you develop during the sprint. And the result of the sprint is the potential release. It's something that you can put in production. Okay, so this is typical cycle that is an iteration or an increment. Okay, so each sprint is an increment. Now, in this context, the question is, how much design should be done upfront? So what is the meaning of upfront? Upfront is before we start the implementation. So when we talk about design upfront, we're talking about design before we start the implementation and before we start writing the code. And this question is a question very important. It's a very important question because normally when people talk about agile methodologies, they don't talk about software design. And if you go to the internet and you see videos about agile methodologies on YouTube, they don't talk about software design. You know, these people talking about agile methodologies. They are project managers. They are not software people. They are project managers. Okay? So there is this concept of the big design up front, and the idea of the big design up front is to do all the design before we start the code. And this is what normally people associate to the waterfall method. Okay? But it's not only the waterfall method. And the problems with this big design up front that we know today that the requirements are always incomplete. It is not possible to have all the requirements before you start the code. And another problem is that the requirements may change. And this is what we see every day when you write software, that the requirements are changing. And here you see a quote from Scrum, that the product backlog is allowed to grow and change during the development. Okay? So you start developing a system and you accept change and you accept change in the requirements. Then some people propose this idea of the emergent design. The idea of emergent design, more or less, is that you don't do design up front, and for each feature, you do the design for this feature. Okay, so in the first iteration, in the first increment, you implement only these initial features that are, let's say, part of the sprint. And then in the next iterations, you add other features, and if necessary, you refactor. This concept of refactoring is very important. Refactoring means changing the structure of the system without changing the functionality. Okay, but this is not a talk about refactoring. If you want, we can have another talk about refactoring, about test-driven development. We can have other talks about other subjects. You can actually ask me which subjects you want to talk about. Then there was this guy called Simon Brown that had this amazing idea and said, let's do just enough design up front. This guy is a genius. Of course, he's right. We need to do just enough, right? You need to do just enough. The problem is, how do you define just enough? How much design is just enough? So this guy gives us the perfect answer. So, but it's useless because he tells us do just enough, but he does not try to explain what is just enough. Okay, so this is Simon Brown. Now I can give you some examples. This is a map of Modi'in. This is not today. This map is at least from 10 years ago, more than 10 years ago. But it's even better. Because when you see this map, this it's not a map, it's a picture. This picture of Modi'in, you see that Modi'in was a planned city. It has lots of planning, lots of symmetry. Okay, many buildings that are identical to each other. Okay, so the city was in the computer before they started building it. So when you want to build a city, you can do it. But if you want to build software, it's much more difficult. By the way, you see in this picture that they also have incremental development. So if you see here in the bottom right, these buildings are ready, but here on the left, they are still under construction. Okay, so you can see here the incremental building development. Now, another very famous city, Jerusalem. This is the old city of Jerusalem. This gate you see here is Jaffa Gate. What kind of design is Jerusalem? Anyone can tell me what kind of design is Jerusalem?
Emerging.
Emerging. This is emergent design.
Which means not planned.
It was not planned. Thank you, Alex. Alex is a very good friend of mine. Welcome. So you see, there is something in the chat. Okay. Wait. Wait. I have a friend joining, Nikita. Let me see. See if Nikita will be able to join. At this moment, do you have any question? Okay. So I like this topic of software design because it never gets old, right? It never gets old. Nikita, welcome.
Nice to meet you all. Thanks.
Nikita, can you turn on your camera?
Wait a minute. I need a moment to turn on.
Okay. So Nikita is my friend, Nikita Zelensky. He's not related to the president of Ukraine. And he's joining us from Russia. Nikita, which city are you joining us?
I'm at Moscow now.
Moscow.
Yeah.
Okay, so my friend Nikita is joining us from Moscow. Welcome. I will continue the presentation.
Moskva.
Okay. So you see my presentation, right?
Surely.
Okay. So Jerusalem is a city that was not planned. So see, you have here the entrance, Java Gate, and then you see here a street. But when you look from the top, you don't see any street. Everything is so close. The buildings are so close to each other that you cannot see the streets. And there is here a grazing. Here, you see my cursor? Do you see my cursor?
Yes.
So this grazing here, it looks like a street, but it's not a street. This is the rooftop of the market. And so this is the Muslim market. Okay, so, and you see that there is a building here that is a triangle. Do you see this triangle building? So this is crazy. They have a building in the shape of a triangle. Okay, very interesting. There are almost not parallel. There are many buildings that are not parallel to each other. Okay, so this is emergent design. And then you have this. This is a building. Anyone want to guess which city is this?
It's each city in
Okay.
Israel.
All cities
It's
in Israel.
like Ofakim or Dimona.
Ofakim or Dimona. Nikita, you want to guess which city is this?
Kiryat Yam, I guess.
Kiryat Yam. Okay, thank you. So this is in Tveria. This is in Tveria. This is a neighborhood called Shikun Dayagim. It's the Fisher neighborhood in Tveria. This building, it doesn't have two windows that are identical. Each window is different from the other. You see this in the right side of the building, this is an extension. It's not original. No, the air conditioners are in random places, one here, random air conditioning. The colors are different, the size are different. There is a dead tree. Now this contributes a dead tree in the garden. Okay? Now, this building, I ask you, when it was new, when it was a new building, it was like that? No. When this building was new, it was not like that. All the windows were identical. All the windows were the same size. All the colors were the same colors. Okay, so this building suffered a process of erosion. During time, it suffered erosion. They even have here a parabolic antenna. So this picture is from before cable TV. They have a parabolic antenna. I don't know, perhaps they're from Yes. No, they have this Yes channel. It was like a parabolic antenna. Okay, so it is a disaster. And this happens to buildings, and this also happens to software.
All the time.
All the time. And this is a quote from The Big Ball of Mud that you must read. This article, the classic in the area of software development. It says the biggest risk associated with piecemeal growth is an incremental growth that will gradually erode the overall structure of the system and it will become a big ball of mud. Okay, so the system will lose its architecture. It will be corrupted. And this happens because of entropy. Entropy is a concept, you know, in physics and other disciplines, but there is entropy also in software. Okay? And there is, I bring here a basic concept that the entropy of an isolated system never decreases. It can only increase, but it can never decrease. And then I bring you the lemon, there are many, two of the lemon laws of software evolution. The first law is that a computer program that is used will be modified. If you use it, you have to change it. And another law is when a program is modified, its complexity will increase. If you change it, it will become more complicated, provided that one does not actively work against this. So work against this is the refactoring. So this work called refactoring is trying to handle complexity. So let's make a summary. So we know that we must do some design up front. We know that big design up front does not support change. We know that emergent design works only at low level for small pieces of code. Just enough can be anything. What is just enough is not clear. And what we need for agile methodologies is a design that supports change. We need a design that supports change. And this is the concept of adaptability that comes from the same article, The Big Ball of Mud, from Joe Yoder. He says, a system that can cope readily with a wide range of requirements. Such a system can allow unexpected requirements to be met with little or no re-engineering. Address novel challenges. You see? So this is the ideal. The ideal for us is to build a software system that we can easily add new requirements or change requirements easily. This is the ideal. And this means we need to adopt a different mindset. Instead of planning for software development, we need to plan for software evolution. And instead of designing a single system, we need to design a family of systems. Okay, so we know that our software system is going to evolve. There will be evolution over time. We know that. And we know that during the existence of our system, if it is being used, there will be many instances. There will be many versions. All these many versions of the system together are a family of systems. Okay, so it's a new mindset. And this is related to the concept of a product line, a software product line that was investigated in the Software Engineering Institute at University Carnegie Mellon. Okay, so a product line is set of systems that share a common managed set of features. Okay, and then they are developed from a common set of core assets. So the idea of the product line is that you prepare these assets, and then from the shared assets, you can build many different systems, many different applications. Okay, and then finally, I bring you my definition of the adaptable design up front. So I say that adaptable software design is a generic software design for a family of systems which does not need to be changed to accommodate new requirements. And I claim, this is my claim, that what we need for agile methodologies is adaptable design up front. And this is what we need. But it sounds like magic, right? I say, does not need to be changed. Is this even possible? How can a person possibly say that I can add new features without changing, without making modifications? This sounds like magic, too good to be true, right? Let's see. There is one of the solid principles. Do you know the solid principles? You should know. One
Yes.
of the solid, who said yes? Who said yes? I didn't see. Nikita?
It was Paula, because we
Paula,
talked
sorry,
about
sorry,
it and
Paula.
appreciate it.
Because I didn't. You said yes. I didn't see who said it. I think we are here today. We are a majority of Russian speakers.
Exactly.
The majority here is Russian speakers. I want to ask Nikita, are you still learning Hebrew?
I tried.
You try? Abisala?
In continuous learning loop. Yeah.
Oh, I'm happy to hear that. Okay, great. It's good news. Hadashot tovot. Hadashot tovot. Okay, so this was defined by my friend Bertrand Meyer. He's French. So don't say Bertrand Meyer. No, don't say Bertrand Meyer. It's not Bertrand Meyer. His name is Bertrand Meyer. He's French. And he said, software entities should be open for extension, but closed for modification. Okay? Open for extension, but closed for modification. You can extend without changing. And here is an example, the strategy design pattern. Who knows the strategy design pattern?
The only one who matters.
The only one.
The only one which matters in architectural
Strategy.
design.
It is my favorite one.
Yeah.
Favorite one. Okay. So the strategy does exactly that. There is some context that uses some strategy, and there are several possible ways to implement this strategy. So you have strategy A and you have strategy B, and then you can choose the strategy you want without changing the context. Okay? You don't need to change the context. You just choose the strategy you want. Okay? Like A/B testing. Okay? Everybody knows about A/B testing, but people don't know about solid. So how adaptable design up front is related to the open-close principle? So we focus on the early definition of the closed aspects of the design, and at the same time, we enable evolution, but making this design open to extensions. This is the goal. We want to separate what should be closed and what should be open. So the closed aspects, what is essential entities and relationships, and the open aspects, mechanisms, I'm introduced to my system mechanisms to enable extensibility. Okay, I plan these mechanisms. And then I give you a metaphor. Do you see this apartment? This is written in Hebrew, Dirat G. What is this Dirat G? Is a kind of apartment, is a class of apartment. This apartment has 2 bedrooms and 1 living room. So it has 2 bedrooms and 1 living room, and it has approximately 72 square meters. And every floor of the building has 1 apartment like this one. So in this building, there are several floors. Each floor has 1 apartment like G. Now, in this apartment, in this drawing, you see some elements that are closed, like the position of the walls and the position of the windows. A person is not supposed to change the position of the walls. A person is not supposed to change the position of the windows. But other elements are open. For instance, there is a table with chairs. Okay, each person will buy his table with his chairs or her table with her chairs. So all the apartments will have the same windows in the same place and the same walls in the same place, but different chairs, different tables, different kitchen appliance. You see? So some elements are closed, other elements are open. This should be something natural. So why don't we do software like this? If when you buy an apartment, you understand that, why when you do software, you don't understand that? Now, let's talk about common mistakes. One mistake is to do too much design up front. Another mistake is to do not enough design up front. Another mistake is too much openness. And another mistake is not enough openness. Now, do you see this device here in the bottom? Who has one device like this at home? Nikita, you have one like this at home?
Similar.
Similar.
With
So-
a long cable, yeah.
Yeah, so you see, this is a typical software. This is a typical software. It has more ways to plug in the back than in the front. Typical software. Okay, so too much design up front. What is too much design up front? Capturing aspects that are not essential as if they were essential. And if you do this mistake, we have to change the system. So for instance, this happens when some specific details were not generalized, or when designed for a specific system instead of designing for a family of systems. Or in other words, when we forget that there will be evolution. If you forget the evolution, you have to change things that you didn't plan to change. Okay? Not enough design up front is when you leave away something that was essential. There are aspects that you have to add later because they are essential. So for instance, when you add some relationship, you had entities and relationships, and you add a missing relationship that you forgot, you have to change interfaces. It's not nice to change interfaces. I can tell you, it's not fun. Changing interfaces is not fun, okay? Too much openness. When the design is over-engineered, You have complexity that is not necessary. For instance, it is always possible to reduce coupling by adding an additional layer of interaction. Okay, so you get the lasagna. Instead of the spaghetti code, you get the lasagna. And with many layers, it is difficult to locate where the business logic is implemented. You have so many layers. Where is the business logic? And not enough openness. You have a design that captures the essential aspects, but you didn't implement mechanisms to allow this to be extended. So you have the main entities, and there are interfaces, but there are not factories. So you built a software without factories. What is a factory? I will not explain now what is a factory, but you should study what is a factory. Design pattern. Now, let's talk about extensible designs. There are several types of extensible designs. We have frameworks. Inside frameworks, we have plugins, and we have platforms. And now I will explain you the difference between frameworks and the plugins and platforms. Do you see this camera? The same camera can use many different kinds of lenses, right? So this camera is extensible. Who has a camera like this one?
Used to.
Yes, today only professionals. Only professionals have a camera like this one. Other people use their iPhone. Okay. Let's talk about frameworks. A software framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code providing application-specific software. Amazing. Sounds like magic. So how many frameworks do you use? Lots of frameworks. In particular, for the UI and the user experience, for the front end. Any crazy person here trying to build a front end without a framework? Anyone crazy enough to build a front end without a framework? I guess no. Okay, Paula wanted to say something. It's better not to say anything.
I just want to say that, but I think we were crazy enough in the beginning of our programming journey before we know about frameworks. In the really, not because of our raison for now.
Okay, yeah, so sometimes you need to try until you understand that it's impossible. Okay, so frameworks are very important. And then we have the concept of plugins. And a plugin is a software component that adds a specific feature to an existing software application. When an application supports plugins, it enables customization. Amazing. Again, sounds like magic. So if we are building a software system, why don't we create our own framework? Let's create our own framework for our application. If we are building our own software system, let's make sure that we can add plugins to our system. Why not? We need to think about this concept of pluggable components, like people used to have on their computers. Now, if you open your laptop, you'll never be able to close it again. It's like a can of sardines. You open the can of sardines, you cannot close it again. And it's the same with your laptop. But people used to have computers at home, computers like this, okay? Do you see? I will stop sharing. Okay, so people at home had computers like this, okay? Everybody at home had a computer like this that you could open and change it and add as many things as you wanted. It was like Lego, It was amazing. Not from Apple. Apple never allowed this. If it depended on Apple, this would never exist. Okay? Apple is a closed architecture. Apple is against this. Okay, Apple is an evil company. Okay, but thanks God, there were other companies that gave us the PC revolution. Any comment? I don't have any Apple product, and I will never buy any Apple product. I only buy for my daughter. My daughter has an iPhone because my daughter is the only person in the world who is able to break me. The only person who is able to break me is my daughter. And then she got an iPhone. Let's continue the presentation.
Yeah, but you're a little bit too, a little bit exaggerating. Apple is good for taking others' technology and make it for the layman and for the simple people. But for those who don't understand what they want to do, you would like to have a framework.
Yes, yes, Alex, you're right. Apple can make things for the simple people, all the simple people that can pay 5,000 shekels for an iPhone. If you're a simple person that can pay 5,000 shekels for an iPhone.
Yeah, by the way, they don't have what to eat, and they're very, very poor, but they will pay 5,000 or 4,000 shekels for an iPhone. That's okay. But still,
Yeah.
okay, Apple is not that bad. Okay? They just
Apple is
they're focusing on other things. Let's not hate everybody, okay?
Apple is an evil company. Apple is an evil company. When Google said don't be evil, it was because of Apple. And that's the reason Google said don't be evil. But let's continue. Let's continue.
Yeah. By the way, Scott McNeely used to say that about the company in Redmond. Back in the 90s, I'm talking about with you about end of 90s and beginning of the 2000s. So everybody has its own,
Bill Gates in his autobiography, The Road Ahead. The Road Ahead is an autobiography by Bill Gates. He said clearly that the most important thing he learned at college was to play poker. Okay, this is his words, it's not mine. Bill Gates said, the most important thing I learned at college was to play poker.
Okay.
Let's continue. Okay, so you have this concept of pluggable components, and you could change these components in your PC, and this enabled customization. This enabled a customization. And then this gives us the concept of versioning. In the traditional concept of versioning, a version is a modification, can be modification plus additions. And after you have these modifications and additions, for each iteration, you have a new version. In each iteration, you have a new version. So after n iterations, you have n versions. But you use components. A version is a combination of components. So if you have a system, now let's see if you're good in math. Yuval, pay attention. If you have a system with m components, after n iterations, supposing that in each iteration we create a new version for each component, then you have n to the power of m versions. Okay? Make sense? So if you have 3 iterations in 2 components, you have 3 times 3. 3 times 3, 3 to the power of 2. If you have 3 iterations and 3 components, it's 3 times 3 times 3. Okay?
Not really, because not all the versions work together, but
yeah. So not all the versions work together. So there are problems with backward compatibility. There are problems with backward compatibility. Okay. Let's continue. And then we have platforms. A platform is a technology that enables the creation of products and processes that support present and future development. So a software platform, it offers services that are used by other applications. So for instance, an operating system. An operating system is a platform. Or for instance, a database. A database is a platform, okay? And then everything that is offering services that are used to create applications are platforms. So again, if I am creating my own system, I can think, perhaps I should create first a platform, or perhaps part of my system should be in the format of a platform. Now, the first question, how do you identify the components in your framework or the services in your platform? You need to identify what are these components or these services. And the answer is domain modeling. Domain modeling, the idea is to create a conceptual model for everything, all the entities, all the attributes, all the relationships that belong to our domain. It's very important to do this exercise of domain modeling. And there are books, there are many books about that. And there is a domain DDD, domain-driven design. And the second question, how do you decouple the components in your framework? You need the decoupling. And to decouple them, we use design patterns. And if you pay attention to the design patterns, most of them are to avoid coupling. Okay? So for instance, you have the observer that enables different objects to react to events. And I will not talk too much about design patterns in this presentation. Let's talk about it in the future. So I talked a lot about some abstract ideas. I want to present you something very concrete. So let's talk about recommender system. This is a project I did at Yahoo 10 years ago. Okay, I'm talking now about a project that was done 10 years ago when I was at Yahoo Labs Haifa. The recommender system has these four main entities. It has historical data, everything that was purchased by the users, all the books that were purchased by the users. It has a model. It is a machine learning model. It has a trainer that gets the historical data and generates the model. And it has a recommender that uses the model to make recommendations. So the historical data is a passive entity. It's just the data storage. The model is also passive. And Nikita, I'm doing here a simplification, okay? I know that this is for software engineers, not for data scientists, okay? And the recommender makes the recommendation using the model, and the trainer uses the data to create the model. Okay, so the flow is first the trainer uses the data to create the model, and then the recommender can make recommendations. And when the data changes, I can update the model and I can make more recommendations. So this is the framework. This is the framework we built in Yahoo Labs more than 10 years ago. And this framework, after 1 year of development, we have 13 subclasses of historical data. We had 9 subclasses of model. We had 9 subclasses of trainer. And we had 19 subclasses of recommender.
How it's possible?
How is possible? This is another presentation.
Entropy.
No, not entropy. Not entropy. This is...
Imagine that, really.
I will explain. Okay, this is an important question. We built a recommender system for TV.
Okay.
It was not about books. The example here is books, but the system we built was for TV. So it includes movies, series, documentaries, children programs, sports, news. You understand? And each one of them is a different approach. So if you want to recommend sports, it must be, you must know for each individual his team. What is his team? if it is Maccabi or Apoel. You know, if you want to recommend sports, you need to know if this person likes soccer or basketball. See, this is for sports. Now, children, it's completely different. Children programs is a different model. Now,
So you're speaking about different data marts.
In this historical data, we have data about movies, series, children programs, news programs, sports events, news, documentaries, shows, music. This historic data is not homogeneous. It's very heterogeneous. And for each kind of a program, there is one model that is the best one. So for some of them, I need to use contextual recommendation. For others, I use collaborative filtering. For others, I just need to measure popularity. Now, if there is something like a show, if there is a show that is going live show, I need to use popularity. Okay, so there are very different approaches. Nikita, did I answer your question?
I guess we could follow.
Okay, so you see, this is after 1 year of work. This is amazing. And then what is the system? What is the recommender system? I choose one class here, another class here, another class here, another class here, and then I build it like Lego. At runtime. When the system is running, it goes to a configuration file, and from this configuration file, it reads the version I want to use, and it runs. So what defines the version is the configuration file. There is no single binary file executable. There is no single executable file for the system. It depends on the configuration. And what about Yagni? People can say, there is this concept of Yagni. You are not going to need it. It's a basic concept of extreme programming. It says, always implement things when you actually need them, never when you just foresee that you need them. Ron Jeffries, this guy is a genius. But he's talking here about functionality. He's talking about features. He's not talking about architecture. He's not talking about infrastructure. He's not talking about expansion mechanisms. He's not talking about frameworks and plugins and platforms. Ron Jeffries is talking about functionality. Okay? And then I say, Yagni tell us to avoid doing what we are not sure we'll need. And Adaptable Design Up Front tell us, define the things you are sure you'll need and prepare for the things that you may need. Prepare. You need to prepare for the things that you may need. And then say, no, I'm going to need it. I'm going to need it. I know I need it because I have been there before. So the conclusions are, software systems must evolve over time. And this evolution should be planned and supported through adaptable software design. And this includes domain modeling, identify the entities and relationships that form the close part of the design, and framework design, create a framework that represents the model and add mechanisms for extensibility. Make it open. Make it open. Some related work for you to have fun during the weekend. Software Engineering Institute from Carnegie Mellon, you have the software product lines. From Alistair Coburn, you have the walking skeleton and the incremental re-architecture. From Neil Ford, you have emergent design and evolutionary architecture. And from Simon Brown, just enough design up front. And then Charles Darwin said that it is not the strongest of species that survive, nor the most intelligent. It is the one that is the most adaptable to change. Okay, this is a basic concept of evolution by Charles Darwin. Okay, thank you very much.
Thank you.
Yeah.
Any question? No questions. You-
So
Anyone here has an iPhone?
I am not very proficient in system design, but what is solid? So,
Solid principles. The solid principles of software design. Let me find the presentation and I will show you. Give me 1 minute.
thank you, Chaim.
It is a bonus.
This is an excellent question. He has a presentation.
Ah, you see? No, normally people say, no, yeah, good question, I have a slide.
No,
I
the
say,
good
no,
question
good
is the
question, I
one
have a
that the
presentation.
lecturer has an answer to. The excellent question is when you have a slide.
Yes. Let me share. Llama.
Llama.
Llama. These are the solid principles. The single responsibility principle, the open-closed principle, the Liskov substitution principle, this is from Barbara Liskov, interface segregation principle, and dependency inversion principle. Okay, and the open-closed principle is from Bertrand Meyer.
So much heuristics there. CAP, SERM, solid principles, acid principles, so new Haim principles or approach.
This is what's good about principles. There are
I
so many
struggle
of them.
to remember all of them. Sorry. Thank you for your answer, Chaim.
Nikita, these 5 things are the cornerstone of every good software programming, software engineering. These are these are evolutionary stuff that started, let's say, 50 years ago, when I first wrote my first program for money. It was in September 74, and everything changed since then. And you know, we went through several evolutions of different software, different hardware, and different software, and speed and whatever it is. But these are the basic principles, and principle means they don't change. Okay, so that's the reason of the principles. Yeah, they don't change. Single responsibility or separation of concerns, it's another word of that, is that it means open close is also part of it. If you do whatever you do like this, you are okay. If you broke it, you will break your scalability. Okay, and other things that you can deal with. So it's not just the thing that somebody created those principles for fun. It's just based on tons and tons and tons of years of experience, and analyzing those from software engineering perspective and not from computer science perspective. And that's the big difference between computer science and software engineering, which are two completely different disciplines. We're normally joking that software programming is not a profession. It's it's a job, but it's not a profession. It's definitely not a science. Okay, so computer sciences is not about computers and not about sciences. It's about software engineering, and that's the big difference here. So it's not that bad. By the way, 5 principles that are not that bad. 2 of those are from the days of the object-oriented programming. The 3 of those are from days back. Some of them coming into 60s. The basic layered architecture that everybody knows, and every framework has layered architecture. They started with David Parnass in 1968. And it didn't change since then, which means that you didn't need to change it. That means that's a good principle and a good idea. So that's what it is about.
Yeah, thank you.
Понятно?
Quite clear, I guess.
Nikita, you know this book?
Ray Dalio, it's another principles here.
This is amazing book. It's a must read. All of you, not only Nikita, all of you here, you need to read this book by Ray Dalio. This guy is a genius. He's a genius, and he's also very rich. Okay, he's a billionaire. He's a billionaire, but you should read this book. Principles by Ray Dalio. This was the advertisement session of this presentation. After I tried to destroy Apple, now I'm promoting Ray Dalio. Okay, any final comments before I close? The only person here who don't speak Russian are me and George and Teila. Teila, perhaps you know Russian and I don't know. Teila, do you speak Russian? No, not even a bisala?
No, not at all.
Not at all. Okay. George, what about you? Do you speak Russian?
Работа, спасибо, пошли.
Поехали, не пошли, поехали.
Great.
Серьезно? Серьезно, George?
Серьезно, серьезно.
Чего?
Okay. Thank you very much. Thank you all. I hope you enjoyed this meeting. I hope it was useful for you. I will continue to invite you for the next ones in the future. I hope you will continue to participate. This meeting will be on YouTube. I will stop recording now. And let me see, where can I stop it?
And could you share your slides?